Hi, my name is Devan, and I'm a rising junior at Lowell High School in San Diego, California. And as you know, my project is the Arduino obstacle avoiding robot for the remote program at Blue Stamp Engineering. Today I completed my second milestone, which was basically getting the obstacle avoiding function to work on the car just by coding it and adding additional pieces. So here's a brief demonstration of this. So I actually did this part of the video later in the day because my project malfunctioned when I was attempting to do it earlier, filming the other part of the video. So I'll just do it right now. After many hours of deliberation, I finally figured out it was a problem with the battery. All of them actually, or three of them. They had lost a significant amount of power, so I needed to replace them. So here is the brief demonstration now. Alright, so we have the car here, and here's the power source, and then once I put on the button, this will act as the wall, and it will show the brief demonstration. So, there. Okay. There's the wall, 30 centimeters, go back, turn this way, there's the wall. And so yes, that is the brief demonstration. The last time you saw me, I had the car up and running, and now the next step was to add the obstacle avoiding function, and the first step in doing that was to add the ultrasonic sensor seen right here. It looks a little bit like WALL-E. Its purpose is to send out ultrasonic waves or sound waves into the air, and then it reads the waves when it bounces back, and it can tell how far an object is away, in centimeters, of course, because it's a metric system, and it sends that information back to the computer. And so when I was attempting to attach this to the Arduino, there were a lot of diagrams online, but they were very conflicting, and none of them could decide on which port to put, which wire to put in which port. So I basically just chose one and adapted my code to contour to this specific diagram. And in doing so, I was able to get this ultrasonic sensor up and running, and I basically could put my hand here and put my hand here, and it could read how far it is away, and that was pretty cool. And so the next part or step in completing the obstacle avoiding function is to add the LED right here into the circuit. And this is actually a very crucial part because it mimics the action of adding the motor and the motor driver circuit to the sensor, because eventually I'd want to have the sensor see something and then have the motors make the wheels turn or go backwards or anything I want, really. And so there were a lot of challenges in doing this because I'm relatively new at using a breadboard, so it was kind of confusing, and I also forgot how to make an LED circuit. I forgot the positive and negative sides of the LED, and I also forgot how to use a resistor and where to put it. So once I figured all of that, it was smooth sailing. I used an if-else statement in my code, which is what it sounds like. If something happens, so let's say if the sensor sees 30 centimeters away, an object 30 centimeters away from anything, so let's just say my hand comes within 30 centimeters, the LED will blink on. Else, or anything else, like if it's 40 centimeters, 50, etc., then the LED will stay off. And this again is to mimic the action of if the sensor sees something within 30 centimeters, the motors will try to maneuver. And so now is the most exciting part, which was adding the motor driver circuit to the actual sensor circuit and the light circuit. So the electrical component was actually fairly easy, but the code part was a little harder because I had to combine three different softwares and had three different functions essentially. So I had to pick and choose the parts that I wanted to go into this code that unified all of them, and that took a bit of time. But once I got all the bugs out, I was able to use an if-else statement and have it so that when it's within 30 centimeters, it turns and goes clockwise, 90 degrees. And after that, I wanted to play around even more with it. So then I was able to have it see something within 30 centimeters, go backwards, and then turn 90 degrees to make it a little bit less likely to bump into things, because what I was finding was that it would turn and then bump into a wall without backing up. So that was a way more efficient use of the sensor. So now that I was done with the coding part, I was able to move back to the physical and electrical component by soldering down all of the wires, and that made all of the circuits permanent and easier because then the wires wouldn't continuously fall out. So that was great. And then after that, I just had one step left, which was to add this portable charger, and I decided to add it to the front because it was out of the way and I was still able to use the cable to connect, and that made everything efficient. And then one last step that I also used was that I added a switch here so that I didn't have, if you can see here, and I didn't have to keep unplugging and replugging the batteries. I can just use a switch now, and I did so through soldering as well. So yeah, that is basically the obstacle avoiding function of the car. And now I get to move on to modifications because I'm done with the overall basic project. And my first modification will be adding the voice control and voice command option to the car through a Bluetooth module and an Android. So that'll be an interesting experience. And that's it for today. I'll see you next time. Thank you for watching. Bye.